Hello, my fellow math enthusiasts. We're doing another straight edge and compass construction in our GeoGebra environment, and we're going to be reflecting a point in a circle. So let's start with a given point and a given circle. And we'll name the point A. Okay? So what we want to do is we want to reflect our point in the circle. And what exactly does that mean? Well, you might think it's something sort of like this, where you get sort of the point right between the closest point on the circle to our given point, and then you get sort of the tangent line, and you reflect in the tangent line. You know, we saw in the last video sort of when we do reflecting in a point, that basically comes down to drawing a line. And the tangent line here would certainly be meaningful. It would be perpendicular to this A in the center point, and that would be perfectly fine. And so it would match with what we saw with reflecting in a point, and it would match with what we saw with reflecting in a line. And you could certainly do that. I'm going to very quickly use one of the other GeoGebra tools to get the tangent line. And we could certainly reflect. You know, here's what you naively might think. And it's not just you who might naively think this. I thought this when I first heard the problem of reflecting a point in a circle. I thought, oh, okay, so you get the tangent point. But it's not really meaningful because it doesn't take the circle into account a whole lot, because as A moves far away, the point gets further away from the circle, and so the circle is not really what matters. It's the center of the circle that we cared about. The circle really didn't do a whole lot. Okay? So the problem of reflecting a point in a circle is a little different. What we want is the point A reflected in some meaningful way to give us a point inside the circle that makes sense in some fashion. Okay? We also have the other problem of what if our point is inside the circle, can we reflect it outside? Right? When we had a point and a line, when we reflected our points in the line, it was sort of a symmetric situation. But you can definitely tell whether or not you are on one side of a circle or not. Are you on the inside or the outside? You can't really say, oh, I'm definitely on the left side of a line or that sort of thing. So it's a different question entirely. Okay. So what are we going to do? Well, we're going to do two different cases. One with our point outside and one with our point inside. I'm going to start with the point inside one, because I think that's a little easier to work with. So I'll make my circle a little bigger. And what we're going to do is we're going to, this is sometimes called making an inverse point, but you can easily think of it as a very meaningful way to reflect in the circle, which is sort of like a very, very curved line. So we're going to connect up the A in the center, and our reflected point is going to lie on this line, just like it would have if we had tried to naively reflect. But we're going to go a little bit further. So we need a perpendicular line through A to this line, so we'll just do it by regular old straight edge compass. Okay. I'm not going to exploit any of the fancy GeoGebra tools right now, because we're doing a straight edge and compass construction, and we want to show how to do everything. Alright, so we get this perpendicular line through A to the line from A to the center of the circle. So this gives us these 2 points right here. Right? And what we want is sort of tangent lines to the circle to these points. Now they're both going to meet at the same location, which is quite nice, and their intersection will, with the line through A in the center is actually going to be our inverse point, or our reflected point from A in the circle. Okay? Well, how do we construct tangents? If we're given these points that we want to be tangent, we only need one of them, but I'm going to do the same construction on both. So you can see that they all really do intersect at the same place, and it doesn't matter which tangent point we use. So we connect them up with the center, and then what do tangent lines do when you drop a radius to them? They make a right angle. So now I need a right angle through these points that's perpendicular to the lines of these diameters, these lines through the center. Okay. So we can really do this sort of any way we want. So there we have one tangent line. You can see, yeah, it really is tangent. So we'll clean some of this up, and we'll get the other tangent line. Now this is enough to get our point, our reflected point. Because it's going to just be this point here, this intersection point of the line that we started with and this tangent line. But I do want to show you that either tangent point would work. Okay, so now we need the line tangent through this point. Okay, well, still perpendicular line through a point. We know how to do this. We've done several of these in this series. Connect up our line, and yeah, it really is tangent. But that's not the interesting thing. Upon further inspection, we see that, oh, yeah, they do all intersect at the same place. And this is the point that we're going to call the reflection of A in the circle. So let's clean this up a bit. So as A moves inside the circle, this thing moves outside the circle. And as A gets closer, our point gets closer, but as A gets closer to the center, this point gets further and further and further and further away. Okay. So this has some nice connections to hyperbolic geometry. As we move it around here, there it goes. So there's our fantastic reflected point in a circle. We can move A, we can move the circle as we wish. Okay. But as soon as we move A outside, suddenly something's gone wrong. Well, we don't get those tangent points because the line perpendicular through A to the center connected up with A doesn't hit the circle. And so now A is the outside point and we want the inside point. So we're going to have to sort of reverse engineer our construction and get back to a point inside the circle. So right now we've got the case of A being a point inside the circle reflected to a point outside the circle. And now we're going to switch things up. We want A outside the circle to a point inside the circle. Okay? So we're going to reverse the construction. We're going to say A is the point of intersection of some tangent lines. So two tangent lines, and then we can connect those two up. And then their intersection with this line A through the center will be exactly what we need. Now, I have shown you how to create tangent lines. We're going to go through it again. So we want tangent lines to the circle through this point here. So we need some other points on the circle. We need some chords. Okay. So connect these brand new points up with the circle. And so we get chords. Get very careful, very careful. There we go. So now we have three extended chords, all of them meeting at A, outside the circle. Okay, we're going to keep our one chord, the one from A passing through the center, but the others, we're done with them for now. And we're done with this big circle. Okay, so when we make this connection, we get sort of this point right here. And this point is exactly the point that we want. Okay. Now we could have used other points, as we did when we were constructing sort of our tangent points. So here we're sort of reconstructing the line perpendicular through our original starting A. And up here are the points of tangency. And remember, when we had A inside the circle, what did we do? We had perpendicular, the line through A in the center, and we got tangent points, and then our tangent points met outside at A. So I'm going to clean this a little bit up. We've already got the point we want. This point here is our inverted point, our reflected point. But I just want to show that we really have reverse engineered the construction. Okay, these are the tangent points that run through A. Okay, and how did we construct our outside point when the point was inside? Perpendicular line through it and the line through the center. Got tangent points, extended those tangent points, and they all met at the same outside point. So A is the reflected point of this dot right here. And so it makes sense that it should be the reverse of A when A is outside the circle. So there we have our reflected point. And as A moves closer, it moves closer. As A moves farther away, it gets closer and closer to the center of the circle. But it's never going to quite get there unless A were a point at infinity. So now we've reflected A in the circle when A is outside. And we've got it reflected in the circle when it's outside. Or inside and outside, yeah. We got both cases, is what I'm trying to say. So I think that's nifty. I also think it's kind of interesting that reflecting in a circle is very different from reflecting in a line and a point. Okay? The curvature, like the size of the circle and then where A is in the circle is very much taken into account. So there you go. And I think that's neat. And hopefully you think it's neat too. And keep watching for more straight edge and compass constructions. I'll see you guys later.